So exercise 2.16, we have a vehicle that experiences a malfunction, it's a guidance system, at an altitude of 250 kilometers, and it has a velocity of 7.791 and a flight path angle of 4.5 degrees. So how can we determine it? Well, a non-stable orbit, ignoring, of course, gravity and all that other stuff that we're not gonna take care of, would mean that the orbit is probably too close to the Earth, and therefore the radius at perigee will be less than the radius of the Earth. So let's check it. How do we actually this altitude? Alt. Okay. How do we find h? Well, h is going to be equals to, and we're talking about just the magnitude of h, so r times v times cosine of gamma. Once I find h, I can find p, which is equals to h squared divided by mu. Once I find p, since p is equals to a times 1 minus e squared. Oh, yes. Well, I don't have a, but I can find at what? No. Hold up. What can I do to determine it? Well, I have r, v, and gamma. I could find zeta. I have v squared divided by 2 minus, we said mu over r, which is equal to negative mu over 2a. Therefore, I find a. Therefore, I find p. After I find, well, I already have p. I can find e because e is equals to 1 minus p over a, square root of this, and then I can find radius at perigee and see, is it less than radius of Earth or is it more? I check, which was equals to, of course, a times 1 minus e. Okay, and that's coded up. So we get all the results. So we have our altitude, which is equals to 250, radius of the Earth is 6,378, velocity is equals to 7.791, and then we have gamma, which is equals to 4.5 degrees. So now h is going to be equals to my radius of the Earth time plus the altitude times the velocity times the cosine of gamma. Then now that I have h, I can find p, because it's going to be equals to h squared divided by mu. That I have p, so let me find a in the meanwhile by saying that zeta is equals to, we said v squared divided by 2 minus mu over r, and then a is going to be equals to then negative mu divided by 2 zeta. Now that I have that, I can find a, which is equal to that, and then I find radius at perigee, which is equals to times z, and I find radius at perigee. It is in fact less than, let me take a screenshot of this, less than the radius of the Earth. Actually, let's close this, let me copy this. Save the clipboard. Now I'm gonna paste it here. Now the value that you're gonna see at the end is the radius of perigee, and the radius of the Earth is at the top of the image, which is 6,378. This is clearly less than radius of the Earth, therefore it's unstable because it's gonna hit the Earth at some point.